Just testing the fit of the stepper motor on this bracket. You see that it's quite simple. We can just do a regular 4-hole pattern which is parallel with the sides, no problem, it'll go straight in. And a nice advantage actually is that the bolts go through from the outside, so it's not that nightmare of stripping things down. We can just take the motor off with the bracket in place. So that'd be nice. How to machine? I got to machine that recess, the 70mm recess, and I got to drill the 4 holes. Well, the 4 holes isn't a problem. How to mount it? I can think of 2 ways of mounting it in a lathe. One is by holding a longer piece of stock in the chuck, in the 3 or 4 jaw chuck, machining the end to accept that hole, and then bolting the bracket to that so the lock turns and I can machine the recess. I can't afford to waste large amounts of stock on mounting, not decent stock anyway, because I can't get hold of it very often. So that leaves another alternative of a long bar in between centres, or from a 3-jaw chuck to a rotating centre. On the centre of the bar I could weld a flange, a piece of plate, which I machine again to suit that. So now this is turning on the middle section of a piece of large diameter tubing, which I can machine again. That's more practical in terms of less wastage, but still a bit of a pain in the ass. But another method is just bung it on the CNC mill table. I can use the probe to find dead center of the hole and mill out the recess and drill the 4 holes at the same time. The problem with that is that this is quite high, and I'm not sure if I've got enough clearance headroom on my mill, because it's not a really large mill, the CNC one at least. So as an option, or the fourth option is use the big mill and use a rotary table. Mount that on a large rotary table, find dead center and mill it out by hand. Now the thing is, with milling out on the rotary table, I can take small, larger cuts, and if it failed miserably, problem with rigidity or anything, then I could always go back and finish machining it on the lathe. So that's not a problem. And the 4 holes, I just bolt it to the mill table and do those 4 holes as a separate item anyway. So anyway, I'm going with the idea of using the rotary table. Now the only thing I got big enough is my 8-inch rotary table here, which I've been actually cleaning up. So it's one I don't use very often because I can't lift the bloody thing. So that's my 8-inch table. As you can see, it's a pretty lumpy bit of gear. Is a fully tilting 0 to 90 degrees. And rather upmarket, high quality mill. Rotary table. Now it's a very smooth bore in the centre bore, so I should be able to set that up on the table with the that coaxial dial indicator. And once I've done that, then the theory would be to mount this on the I can mount it actually with one bolt genuinely in a slot, and moving the other one, I'll have to clamp the other side. Will that be strong enough? I might put a bit of paper in to get more grip between the 2 metal surfaces. And will that be enough to be able to mill? At least I have got the clearance for it to do it. So that's the intention. That's what I'm going to go with. At least try this method. Well, the first stage of doing this is cleaning up, polishing up that internal diameter. Simply because that's what we're going to use on the DTI gauge to. And we wanted a nice smooth surface for the indicator to slide on without jumping or the needle jumping. What I use for that is usually a sort of 400 grade wet and dry, and I use degreasant, you know, like engine degreaser. I keep it in a teapot because it's easy to use. I mean, that would be the normal place to keep degreaser anyway, wouldn't it? Yep. Yeah, that's good. That's good. Okay, so next stage. I think what I'll do is do it in two totally separate operations. I'm going to bolt this onto the table of the mill, find dead center, drill the 4 holes, and then there's a second totally separate operation. We'll do the mount it on the rotary table and do the center cutout. Generally speaking, once I fit a vise on the mill table, I don't like to take it off unless it's absolutely necessary, because I normally line it up so it's truly parallel and so on. So it's I usually leave it there unless I've got a job where I absolutely need to remove it. And of course, to fit the 8-inch rotary table here, I definitely will have to take this one off. So that's what I do now. I don't normally use compressed air all over the place. I don't like it where it blows a swarf everywhere. So wherever possible, I'll simply brush off the. Okay, I've just torn up some old scrap paper I found here, which I'm going to pop underneath the feet. This way I can make sure, well, reduce the chance of it slipping. I'm not going to apply any side pressure here, so it's all we're doing is going to center drill the 4 holes. I'll use the laser. Right, I'll zoom in. I don't know if you can actually see what I'm doing. If I zoom right in, there, you'll be able to see the laser. Right. That really ain't too bad there already. I think I've mentioned this before. If I zoom out slightly now, you've got the laser light on the top and also on the bottom of equal brightness, so that's what I'm aiming for. Now this end, I'm still got a light at the bottom and a light at the top. To me, that means it's pretty parallel. What I'm going to do is just nip up the bolts. that should be pretty solid. We just try this once more now. I'll increase the brightness just so you can actually see it. Yeah, I'm happy with that. Well, I've just set up the coaxial dial gauge, and it's something I just don't like with these, and it's the length. In order to sort of center that hole, the table's right down as low as it'll go, or well, almost, and there's this enormous length of the probe system. Any tiny errors is going to get multiplied. That's what common sense tells me, and this is why I don't particularly like this idea. So what I'm going to do, I'll use the sort of standard edge finder and find the edge of the holes. That means it'll be much shorter. Be much shorter by using the edge finder to find the center of this hole. But what I'll do is I'll set it up using the coaxial indicator as I've got it set up here, and then I'm going to wind the table up. I'm going to set it up and do the edge finder and see what the error is between the two. This will be an interesting exercise. Okay, I'm going to run the coaxial up and center this out. Happy with that. If I zoom in, that ain't bad, is it? Right, now we'll go on to the second method. I'll zero out the table. Well, there you can see, I don't know if you can see the results. I don't know if you can see the results here. But quite a bit off actually. Instinct tells me this is probably the most accurate method, because I've tried it several times, and each time I've had exactly the same reading on the drill when this thing's popped off. So I'm going to go with what I got up here rather than what I got down on the end of a long chain of bits and pieces. Just as a last resort, I'll run I can run the laser finder as well and find the edges. This is another method, and check all three.